Hello everyone, in this video we are going to talk about interaction. What do you think about interaction? Pause the video and think about it. This is the picture of the water and the water molecules, and what does that remind you of? What do you think? Okay, if you answer to that question, which means what are you thinking about interaction, maybe you got some response for this picture. As it shows the water molecules, let's say interactions occur between all objects, even those as small as water molecules. So the purpose of this picture is that because it wants to show you the interaction between water molecules. So we have the water molecules like this, and we have the negative charge over here and positive over here. And this is only one water molecule. And how does these water molecules are interacting with each other? One side of each molecule is slightly positively charged and the other side negatively charged, so that water molecules are attracted to each other. Yes, and how does it happen? Something like this, so that you can see that the next water molecules, which has the negative charge over here, can be like this. And this area again like this. So with the water molecules, yes, and this part could be like this. So this means that each side of the water molecule has either positive or negative charge, and then they can attract each other like this, or here like this, or here. So these water molecules are attracting each other, so that makes the interaction. Because of these electrostatic interactions, the surface of water behaves as though it is elastic. The water molecules are interacting with each other and makes the surface like an elasticity characteristic will give to the water molecules, or we call it like surface tension. What do you think about this? So cool. You see that this is something not on the earth, should be outside the earth, right? Yes. By understanding interactions and being able to predict their outcomes, scientists have been able to send probes to distant parts of the solar system with amazing precision. For example, the rendezvous of the Rosetta probe with the Comet 67P. Have you heard about this before? Okay, I have done search for you, but you can do the search for yourself as well. Pause the video and have a look at what is the Rosetta probe with the Comet 65P. There are very nice stories around the internet. In this example, the main interactions were gravitational forces which act between all objects with mass. So the purpose of this example is because of these interactions that was between the gravitational forces and the all objects having mass. So this is why we give this example as an example of interaction, to show that how all the masses, all the objects having mass have interaction based on the gravitational force. Here we go. These are the two YouTube videos, and I'm going to watch this video and show them so that we can see together.
It's hard to forget a mission like Rosetta. It had joy, emotion, a few tense moments, and drama. After the Philae lander's 7-hour descent to Comet 67P, for instance, it bounced across the surface and went missing. But a few weeks before the mission ended, a member of the Osiris team struck gold.
I was the one who has found Philae in the images, so it was amazing, and I still get goosebumps now whenever I talk about it.
Philae provided views from a comet for the first time in history, while the orbiter's Osiris camera took 100,000 images during the mission. All are archived. And despite Rosetta's official end 3 years ago, the science continues. 21 instruments studied Comet 67P, and in doing so, transformed not just our understanding of cometary science.
Rosetta is probably one of the most important missions ever flown, because it changed our perception on how the solar system formed, where the material comes from, which made the planets, and probably also how life started.
Recently, scientists found new evidence connecting comet outbursts with cliff collapses and bouncing boulders. And at ESA's ESTEC site in the Netherlands, scientists at the final Rosetta Science Working Team, or SWT meeting, shared the latest analysis of their data.
Any comments or questions?
The teams had been really focusing on operations during that hectic period for 2 years around the comet. So we needed that time, or this last 3 years after the end of the mission, to really make sure that we have the best quality data that is the legacy of the Rosetta mission.
While some of the Rosetta scientists will remember its launch in 2004, for others, it's been the start of their scientific career.
When I arrived in the Midas team, I was still a student, and I joined the principal investigator, the PI that was back then operating the instrument. And I had the possibility to help him operate the instrument. Then I got some funding to do my PhD thesis, so to do some scientific analysis of the data. And eventually I even became the PI, the principal investigator myself. So this was an insanely steep career, and I think also a great personal development for myself. And I think this was possible because the Rosetta team really embraced me and helped me to get where I am now. And I'm very thankful for that.
The next generation of scientists are now taking the knowledge they have gained from Rosetta onto future missions.
Now that Rosetta is over, obviously I'm going to continue doing the science because there's much that is left unexplored. But we do have another project in mind, which is Comet Interceptor, which is a really cool new mission that was just selected by ESA to intercept a dynamically new comet, so a comet that enters the solar system for the first time in its life.
Rosetta's past, continuing science, and influence on future scientists ensures that this extraordinary mission will not be forgotten. It's been an extraordinary year for the Rosetta mission. Since landing on Comet 67P Churyumov-Gerasimenko, the combination of continual data from the orbiter with several days' data from the Philae lander has provided a comprehensive picture of a remnant from our solar system billions of years old. Recent images of the comet have revealed unusual terraces or strata, rather like the layers of an onion, as well as pits containing walls up to 400 meters high. These layers help scientists determine that the comet was formed by a collision between two comets, resulting in its distinctive rubber duck shape. The comet has no magnetic field, but Rosetta has identified a number of gases from the nucleus, including water vapor, carbon dioxide, hydrogen sulfide, and even argon, the first time it's been detected on a comet. These gases were traced by Rosetta's Rosina instrument, and its laboratory is based here at the University of Bern in Switzerland. The latest discovery is familiar on Earth, but not on a comet.
The biggest surprise so far is certainly molecular oxygen, because that was not expected at all. And this tells us a lot about where this material comes from, where it was formed. It correlates very well with water, and I think, I'm not sure, but I think it shows you that the water was formed in the molecular cloud and not in our solar system. It was already existing when it entered the solar system.
The water coming from the comet was also shown to have a different isotopic ratio to that on Earth. The unusual shape of the comet, with one lobe much larger than the other, means that as it spins through space, parts of the comet are often in and out of shadow. The Virtus instrument has revealed how water has been transported from within the comet to its surface via sublimation, where water changes from ice to a gas without going through a liquid phase.
We measure the abundance of ice and the temperature in different points, getting closer to the shadows. And you see an anti-correlation. When you have the maximum abundance of ice, you have the minimum temperature. As soon as the temperature increases, the ice diminishes, because it's sublimating away.
These images show the changes on the surface from red, with no water ice, to blue, where ice has appeared, all within several hours. The European Rosetta mission covers many facilities across numerous countries. At ESA's European Space Astronomy Centre in Madrid, you can find Rosetta mission manager Patrick Martin.
The mission extension will last until end of September next year, and the idea is to spiral down the orbiter, Rosetta, toward the comet, slowly, diminishing its altitude, and then settle the spacecraft on the surface, hoping to be able to control it as long as possible.
When Rosetta descends towards the comet, it will enjoy an equally close-up view to its Philae lander 1 year ago. By then, the mission will have used 21 different instruments to study a comet at all stages of its activity, from approaching the Sun to being at its closest distance or perihelion, to moving away from the Sun back towards the cold outer reaches of our solar system. It will provide insight into our planet's own formation by giving us the most detailed knowledge yet of a comet.
Next slide. What do you think about this picture? Yeah, this is a 305 meter or 305 meter radio telescope at Arecibo in Puerto Rico. Is a part of a network of observations that are attempting interaction with life elsewhere in our galaxy. That's so fascinating. You know, you see, there is something that they want to find out if there is a life in other galaxies. That's so nice. Thank you. And for this program, which is called SETI Program, if you pause the video and search for SETI Program, you will find very nice, interesting areas. I did and I will give you my research as well, but you do it by yourself. So the SETI program searches for transmissions from intelligent extraterrestrial civilizations, and the MYP program transmits messages that distant civilization might receive. You see, so one program is for the messages that you may receive from aliens, and the other program is when you send a message to them. Though we would not receive, and the cool part is here, though we would not receive any responses to these messages for thousands of years. I'm so sorry, I just disappointed you. I started with a very fascinating topic, but then at the end, we haven't received any message unless we made some movies like E.T. or other alien types that they are invading our planet. Yeah, but anyway, we don't need aliens. We have coronavirus, and he himself is killing everyone. No need to aliens to kill us. Here we go. It's not a movie, it's a Wikipedia. So I click the link and we will check out whatever written over here. Yes. Here is the link for search for extraterrestrial intelligence, which is the abbreviation for SETI, and you can see that S for search, extraterrestrial intelligence as SETI. So the cool part is that for example, they monitor electromagnetic radiation for sign of transmissions from civilizations on other planets. Yeah, it's so cool. And scientific investigation began shortly after the advent of radio, when they found the radio. Can you see that? So old. In 1900. So that is like more than 100 years ago, more than that. So they focused their international efforts. Their international efforts has been going since 1918. However, they have tried to do this kind of investigation since the radio has been discovered. In 2015, which is quite a new time, Stephen Hawking and Russian billionaire Yuri Milner announced a well-funded effort called Breakthrough Listen. Okay, so this is the link. If you want to get more information, it's up to you, no problem. Go ahead and read it by yourself. Introduction. Let's talk about the key concepts and related to the key concept, and then the global context. So for that interaction, definitely the key concepts would be relationship. Why relationship? Because people, organisms, molecules, they have interaction. So this means that they have relationship. There are relationships between themselves. So that's why the key concept would be relationships. Statement of inquiry. When two or more individuals interact, they form relationships that over time impact and contribute to their identity. So I really love this statement of inquiry. Don't you feel so? It's really beautiful. Interactions are effects that things have on each other. The things could be living organisms, systems within organisms, non-living objects, or chemical substances. So anything could be included in interactions. Physics investigates fundamental interactions such as gravity, electromagnetism, interactions which have predictable results. What about bio? What about bio? What do you think about biology interactions? I think it's too complicated. Let's see. Yes, in biology, interactions are much more complex and their outcomes are harder to predict, but they are nonetheless important. Interactions with other animals, with other humans, and especially with our colleagues, friends, and family allow us to build relationships that shape our identity. That is so, I really love this sentence. Relationships that shape our identity. Really, really nice. The global context of this chapter is therefore identities and relationships. This is so cool. You cannot believe that in this textbook, this is something about the Chinese, old Chinese history. And I would love you to go and find this history because it is so nice. Let's read together. The Four Pest Campaign was begun by Mao Zedong, am I right? Zedong, in 1958. And the Eurasian tree sparrow. So there is a sparrow. You know what is a sparrow? Eurasian tree sparrow was one of the targeted species because it was eating some of the nice grown for human consumptions. So sparrows were eating rice. Why did they do that? And then that campaign, what happened to that campaign? The campaign was successful in almost eliminating tree sparrows from China in the years that followed, but there is a big but over here, but because they also eat locust and other insect pests of rice crops, the result was a substantial decrease in food availability rather than an increase. So important when you want to do some research on biology, you have to think about all the interactions, and this is very important in ecology. What happened next? This shows how important it is to understand interactions in biology. So cool. I love this painting. Really nice. So interactions between animals are the main focus of this chapter. We are talking about interactions of animals. Some relationships between animals may seem one-sided. For example, the predator harms its prey by killing and eating. But every species has effects on other species, and animals in a group all affect each other. Can you tell me what is the relationship in case a predator harms its prey by killing and eating? What do we call it? Pause the video and think about that. What kind of relationship is that? Interactions between animals involve responses. Most of these responses are mediated by the nervous system. So, in this chapter, we consider how sensory information is processed and how decisions are made that lead to a response. We need to know how a nervous system is working. Interactions between species can be analyzed to find whether they are beneficial or cause harm. This is what I mentioned over here by asking you this question. What do you think about the type of the interaction between these? For example, a mutualistic relationship between two species benefits them both. Okay, so if there is an interaction between both and both of them are getting the beneficial, that would be the mutualistic both of them are getting benefits. But parasitism is an example of a relationship that benefits one species and causes harm to the other one. That's why we call them parasites. So only parasite is getting the benefit, but the other, get harmed. So relationships that harm both species are unlikely to persist. Yeah, if the relationship between two species, both of them get harmed, what do you think? Can you give me some example? Can two people harm each other? And if these two people harm each other, what happens? Yeah, they are separating. That's so simple. So two people cannot harm each other. They separate because this is not biology. This is not science. Yeah, that's a nice story and lesson here. In this chapter, we look at a wide range of types of relationship, and this is therefore a key concept. Again, relationship as a key concept. A cheetah stalks its prey using sensory receptors and its nervous system to decide whether to begin a chase. So, this is the nervous system who decides about how to start to grab the prey. This depends on how close the cheetah can get to the prey before it's detected. So that's why we are going to talk about the sensory receptors in the nervous system. And specifically, we are going to have some lessons regarding the nervous system, neurons, and how the signals are passing through the neurons. And another interaction which shows the beneficial relationship, mutual beneficial relationships between these different fishes. Blue-green chromis, these are blue-green chromis. You can see from the color as well. And with the golden dam sailfish, So this is a golden dam sailfish, and I don't know which one is the third one, blue streak cleaner raceae. Maybe if I can search, I will find that. But anyway, it doesn't matter. The point is in this slide is that these different types of fishes, different types of fish are having a mutual beneficial relationship. And this mutualism are so many different types of mutualism. If I'm going to continue or start the relationships and the interaction between the mutualism and parasitism, is completely like a few lessons, and it is too much to talk right now, and we are getting away from our topic. So let's focus on our topic, which is focusing on the interaction and the relationships. And I think this is the last slide before the next video.